Hi folks, so what we're going to do in this video is a little bit of road geometry, and these 4 questions here guys are going to be specifically kind of aimed at the higher level aspect, okay? We've done other videos on road geometry, and on the higher level aspect there's kind of another step that they push you on with. So we're going to learn a little bit about that there today. It's where basically the roads are not level anymore and they might either be rising or falling at a steady rate, okay? So what I'll do as always is start with the first question and zoom in on that there now. So for question 1, it states the map shows ground contours at 10 meter vertical intervals, so that's the distance between our contours, 30 to 40, 10 meters difference. The proposed roadway rises from X to Y at a continuous gradient. So you can see here with X here and Y here, what they're saying is the roadway is not level anymore, okay? It's actually rising, okay? Which basically means it's going up at an angle. A and B are points on the central line of the roadway at altitudes of 70 and 80 respectively, so I'll just underline that and that. So basically at A I have at 70 and B I have 85. Using side slope of 1 in 1 for our embankments, fill ratio is 1 is 1. Complete the earthworks necessary on the southern side of the road necessary to accommodate the roadway. So first of all, our fill ratio is 1 is to 1. Okay, now our scale is 1 is to 1,000. Now we've done this before. That means 1 millimeter on my sheet, so I put in OS there, is to 1,000 millimeters in reality, IR. So 1 millimeter on my sheet, okay, equals 1,000 in reality. What we have to do is we have to work up to 10,000, because 1,000 is 1 meter, we have to work up to 10 meters. So I'll multiply this by 10. So 10,000 millimeters in reality equates to 10 millimeters on my sheet. Okay, because I multiplied this by 10, I also have to multiply this. So 10 is kind of the number we're going to use there. We're going to apply that to our fill ratio, and our fill ratio we're going to multiply. So for every 1 millimeter I step out or I step down, I'm going to also step out 1. So essentially 10 is to 10. Okay, so that's our fill ratio. Now what we're going to do, I'm just going to come over here, and we can see here I've kind of done just a little quick sketch there of a roadway where A is at 70 height and B is at a height of 85. You can see the roadway has increased in height here. Now, what we're going to have to do, and it's something slightly different here. Usually in our previous questions we would have stepped out from the road by applying our fill ratio, 10 millimeters, just done parallel lines with the road. Now here what we're going to do is we're actually going to have to apply a fill cone. So what that means is, if I was just to do a cone there, put in a little triangle here, and obviously the height difference is 15, okay? You can imagine that was a portion of a cone there, like that. And essentially that cone is going to represent the height difference from A to B. Okay, and we know the height difference in this case from 70 to 85 is 15. Okay, so we're going to set out a 15 millimeter radius cone. And how that would appear on our sheet is essentially a semicircle or a quarter circle. And what we do then is, from A, we're going to connect that as a tangent. Let me do a little bit better there. And that's going to be the line that we are stepping out parallel to them. And from every one of them, if this is at 70, the next one out will be parallel to it, likewise, and so forth. Okay, and it'll keep continuing there. Okay, and we know when we're filling, the reason for that is because the land is lower. So every 10 millimeters that I step out, because that's my fill ratio, that's going to go down to 60, 50, 40, and so on. Okay, that's how it appears on our page, and we're obviously getting just a bird's eye view of that. But that's kind of like a little, I suppose, a neat 3D sketch there of kind of what's happening on our page in a moment. So, with that in mind, what we're going to do is we're going to complete this question now. So I'll just grab my set square there, and at point A I'm going to do just a vertical line up and down through point A, and the same for B. And at the point here for point B I'm going to get 15 millimeters on my compass. Okay, and that 15 millimeters is to represent the distance between point B and point A. 85 takes 70, 15 meters. Okay, so 15 millimeters on our sheet. What I'm going to do is I'm going to put in my fill cone. just like that. Okay, 15 millimeters. From where A is at the side of the road, I'm going to construct a tangent. Okay, and that tangent is level at 70. Okay, now from that tangent, I'm going to measure out in increments of 10 millimeters. Let's put the T-squares over there. I'm going to measure out in increments of 10 millimeters. So usually here what I would do is rotate my set square so that I kind of have a perpendicular line to measure from. Something like that. And then I can measure out in 10 millimeter increments accurately. So 10, 20, 30, 40, might go one more, 50. Those are the marks there. A series of parallel lines now. So if that was at 70, this one's going to be at the 60. So I'm just going to mark 60 there and there, keeping it neat and tidy. Next one's going to be at the 50. I'll actually put in the lines completely for the first video actually. So there's the 61, 50, 40, and 60, 50, 40. I think it goes down to 30, yeah. And actually something I forgot to do, apologies for that, marking upwards. So if this one's at 70, going upwards this will be 80, and so on to 90. I'll just put those in as well to have them done. Still parallel there. So here's the 81, and 90 is going into the road, so I don't think that one will affect us. So I'll just write those in at the side. 80, 90, 60, 50, 40, 30. Okay, now it's essentially locating where these pass through our contours. So the 31 is here and here. Then I've obviously got the 40 here and here, 50 here and here. So this is the 60 here and here, and then the 70 contour is there, and just follow it around. It's right over here, close enough to the road, and just a little bit in behind it. Okay, and finally the 80 contour followed up. There's the 80, and my 91 will be here. It's just to give me a little guide. So what I'll do is I'll quickly sketch that in. So there we have it, folks. That is the first question completed on that page, and as you can see I just kind of sketched in where the points were passing through the contours, and then I put in my tadpoles to identify that it was a fill that I was doing. When it's a fill, if you imagine a ball was at the side of the road, it's going to roll away from the road down the hill. Okay, hope you found it helpful, guys. What we're going to do now is going to move on to question 2 at the right hand side of the page. So for question 2, guys, it says the map shows ground contours at 5 meter vertical intervals, so you can see the distance between them is 5. The proposed roadway rises from X to Y at a continuous gradient, X here, Y over here, so it's going upwards again from X to Y. A and B are points on the central line of the road at altitudes of 40 and 55, so A is at 40 here, so just write 40 in there. B is at 55. Okay, so we can see the difference in height is 15 meters between them. Using side slopes of 1 and 2 for the embankment, so our fill ratio is 1:2. Complete the earthworks necessary, okay, and our scale is 1:2000. So as always with our scale, like in the last question there, 1 millimeter on my sheet equates to 1000 millimeters, so I'll just put in OS there, IR. In reality, we want to work up to 5 meters difference, okay, in between them. So what do I multiply this by to make 5 meters? Well, I multiply it by 5 to make 5000 millimeters. Therefore, I have to multiply what's on my sheet. So 5 is going to be kind of our magic number there, okay, that we're going to use, and we're going to apply that to kind of our fill ratio. Now our fill ratio in this case is 1:2. So what that means is for every 1 meter I step down from my fill triangle, I'm going to step out 2. So 1:2. That means I have to apply this 5 to this ratio. So 5 times 1 is 5, and 5 times 2 is 10. Okay, so if I step out, essentially as we see, we only see the line stepping out because obviously it's a plan view here. So 10 is going to be the number. The 10 is the distance I'm going to step out when I'm putting in kind of my fill lines, okay, to cut through my contours. Now, just relating over to this, in this case, once again, okay, in the last one it was obviously 1785, and in this case it's actually, this is 40 and 55. So A is 40 and B is 55. So scribble out that there, and I'll scribble out these guys as well. Alright, so it's going to step out from the road, and it's obviously going to go in 5mm increments this time. So it'll go 40, 35, 30, 25 and so on. But what's important here is we actually have to work out what our fill cone is. Now, our fill cone kind of follows the same principle as our fill ratio. The difference in height from A to B, 40 to 55, is 15. Okay? But our fill ratio is 1:2. Okay? And we apply that principle as well as we're stepping out from the side of the road. Okay? So if you remember, 5 times 1 was 5 and 5 times 2 was 10. We're going to multiply the 15 by the fill ratio. Okay? And 15 times 2 equals 30. So our radius here for our fill cone is actually going to be 30, not 15 this time. So that's what we're going to apply. So first step we do, we get 30 on our compass, 30mm. Yeah, have 30 there. And like the last time, what I'm going to do is from A and B, just want a very vertical line. Up there and there, and from point B I'm going to put in my fill cone as it would appear in a plan view. Okay, and once again then from point A I'm going to construct a tangent to my fill cone. That there is at 40mm. Now, once again, so I can measure accurately, I'm going to construct a perpendicular line to that tangent, just so I can measure from it. And I might go down just a little bit further. I'm just looking at my contours. They're actually going higher in this case. 30 is the furthest it goes down to, so I think they should actually be okay there. Now, we're going to measure down in increments of 10mm if we remember applying our ratio. So this one's at 40, I'll actually put it about here. So I'll measure upwards as well. So I'm measuring in 10mm increments because I'm applying the fill ratio here. So if this was 40, this one going upwards is going to be 45, 50, 55. Even though I have obviously measured in 10mm increments, it's only going up in steps of 5. Okay, going likewise, sorry, forgot one down here. I've got also 35, and I'll obviously have to put in 1 or 2 more because I can see I have contours here as well. But I'll start stepping those across. So this time, working on the southern side of the road first. At the 45 point here, I'm just going to mark it. So there's my 45. Same with the 50. Same with the 55. Oh, and I have one more actually. Measure up another 10. That one's at 60. Now I put the 61 in, even though it's going into the road, it gives me a guide. My 41 obviously passes through, just finding it right here. Now I have to find my 35. Okay, and I'm going to step down, going off the sheet slightly now in the picture, but at least it'll give me a guide. So I'm stepping down. I know it's slightly out of camera shot. So there's the 35, down to the 30, 25, and I have one more, 20. Okay, so there's all my marks there, so I'll quickly sketch that in. So there is the earthworks done on the southern side of the road. Now once again I'm going to do the exact same process, only this time completing it on the northern side. So once again applying my fill cone. Has a radius of 30. Construct my tangent. That tangent is at a distance of 40. And once again getting a perpendicular line to measure from accurately. This time I'll actually do it from this side here, I think. Obviously you'll be using pencil on today, might look a little bit neater than I'm doing it here. It goes 35, 30, so I need to step up 2 here. 35, 30 is as far as it goes. Does it hit to 25? It won't hit to 25. Okay. 40, 50, 60, sorry, 40, 45, 50, go 55 here, and 60. So as I said, here's 40, 35 and 30, 45 is there, 50, 55 and 60. So series of parallel lines, or just identify the marks. So I'll mark the 30 first. So there's 30, 35, 40 is right there, 45, 50. Does the 55 hit it? Yeah, it does. And we'll see does the 60 hit it? Right in there as well. So once again, sketching your curve. So there we have it, folks. There is the the fill lines put in for this question. That's question 2 complete. So what we're going to do now is we're going to move on to question 3 at the bottom left of the page. So for question 3, it states the map shows ground contours at 10 meter intervals. So the gap between our contours is 10. The proposed roadway falls from x to y at a continuous gradient. Okay, so in this one it's not rising, it's falling from x to y. So A is going to be the highest part and B is going to be the lowest part. A and B are points on the road, okay, at altitudes of 90 and 80. So A is at 90, B is at 80. And using side slopes of 1 and 1 for our fill ratio for our embankments, complete the earthworks necessary. So look, as always, our OS on sheet is 1, IR is 1000 millimeters. We need to work up to 10, so multiply 1000 by 10, also multiply what's on my sheet. So there's kind of our magic number there. Now what we're going to do is we apply that to our fill ratio. Okay, so I'll just put in fill R here, and our fill ratio is 1:1, multiply 10, so for every 10 millimeters I step down, I'm also going to step out 10 millimeters. Okay, so that's the distance we're going to use. Now, in this case, A is actually the highest part of the road and B is the lowest part, so in this case the road is falling. In previous questions, from A to B the road is rising, this time it's falling. Now we always, when we're putting in the fill cone, okay, we always put the fill cone in at the highest part of the road. So this time the fill cone is going to be at position A. So we use our ratio, so the difference in height between A and B, 90 to 80 is 10, so 10 meters in height. We apply that to our fill ratio, 1:1, so 1 times 10 is 10. So I'm going to get 10 millimeters on my compass and do it from the highest part of the road. In this case, it's actually at A. So from A, I'm going to put in my fill ratio, and I have to do it on both sides of the road. I'll say my fill cone, I mean. There we go. And on both sides of the road then, construct our tangents. And this tangent is coming from the lower part of the road, always going to be at 80. So that's it done on both sides there, both coming from a height of 80. And what we're going to do is we're going to step out in increments of 10 millimeters, okay? So it'll be going 80, 70, 60, 50, 40, okay? That's what we're going to do. So, as always, I'm going to get a perpendicular line to do my measurements from. Just see it here, 80, and it seems to go down. So it's only going to be going downwards in this case. So I'm going to do a perpendicular line, just do my measurements from. Do it about here, I think. And I'm measuring increments of 10, so that would be 90, so 70, 60, 50. I'll go down to 40, I think. There's 140 there. Yep. I'll also do the same going upwards, just to have it done. And once again, measuring in increments of 10, 70, 60, 50, 40. Just mark those in. Okay, now it's a case of doing a series of parallel lines. In this case, I'll actually just keep it neat and tidy. So the 81 passed through right there, 70 passes through here, there's only 170, the 61 passes through this one, so I follow my contours, and also over here. And actually, sorry, the 70 does pass through another one over here, and the 80, if I continue it on, passes in here. So if I follow that over, follow the contour down, now I'm down to the 51, so 50 here and here, and finally the 40 here. So that's the southern side of the road. Now I'll do the northern side. So parallel, so here's the 80, there's another 80 down here. I want to follow the 70, I think there's 70 over here, yeah. 60, 60, then up to the 50, and the 50, and finally 40. Okay, so you can see the marks there. So as always, I'll speed up the video for this part. So there we have it, folks. That is the third question done. In this one here, the slight difference was that the highest part of the road is on the left and the lowest part is at the right. As long as you recognise that you have to do your fill cone on the highest part of the road, you should be okay with that one. So what we want to do now is we want to move on to the final question at the bottom right of the page. So the last question on this page, folks, it says the map shows ground contours at 5 metre intervals, so the distance between our contours is 5. The proposed roadway falls from X to Y at a rate of 1 in 10. Okay, so that's important there. Falls from X to Y at a rate of 1 in 10. So basically the road, the highest part is at X, the lowest part is at Y, and it's falling in this ratio or at a rate of 1 in 10. So for every 1 metre I go down in height, I travel 10 metres along the road. Point A is on the centre line of the roadway, has an altitude at 80. Okay. We don't have a point B, and it says using side slope of 1 and 1.5 for embankments, or ratio, fill ratio is 1 and 1.5, complete the earthworks necessary. So as always, we'll apply the scale. Our scale is 1:1000. So we know this, 1 millimetre on my sheet equates to 1000 millimetres in reality. So I have to work up to 5 meters difference, so I multiply this by 5,000, so multiply on my sheet. So 5 is kind of the number I'm going to work with, and I'm going to apply that to my fill ratio. So my fill ratio is 1 is to 1.5. So 5 times 1, so for every 5 meters I step down in height, I'm going to step out 5 times 1.5, 7.5 meters. So that's going to be the measurement. Okay, 7.5 millimeters, sorry, is going to be the measurement I step out for getting my contour heights of where it intersects with the contours. But now what I have to do is I have to apply this part, because I don't have a point B on the road like we've had in a previous question, where we kind of have a reference of where we're going to construct our tangents to our fill cone. Okay, so but what they do tell us is that the road falls from X to Y at a rate of 1 in 10. So I have a little sketch done here. And I have the road, the highest part up here at X, the lowest part at Y, okay, and it's saying it's falling at 1 in 10. So essentially what it's saying is, for every 1 metre I travel down, so let's say that was 1 metre down there, I'm going to travel out 10 metres, okay, and that's what's happening here. So if we imagined X was at 81 meters in height. Well, for 1 meter I travel down, I go out 10, I get to point A, which is at 80. So that's now down to a height of 80. So what we have to do is we have to apply that to help us find a point B on the road. Okay, and if we work up in kind of round numbers, if you think 10 meters is kind of difference, 80 take 10, we want to get to a height of B where it's at 70. Okay, so essentially how far do I have to drop in height to get to 70? And how far along the road do I need to be? So if A is at 80, I need to get down to 70, so I need to drop 10 meters. Okay, so if I multiply 10 times 1 in height, that's going to be obviously 10. But that means if I'm falling in 10 in height, I'm also going to travel how far on the road. So 10 times 1 was 10, 10 times 10 is 100. That means I'm going to have to travel 100 meters along the road to get to B, which is going to be at a height of 70. Okay, and how that would appear if we were drawing it in 2D is essentially, if A was here, that's at 80, I've gone down to 10 meters in height, now B is going to be at a height of 70, but basically means I've travelled 100 meters from here to here. Okay, so we're going to apply that to our question here. So, with that in mind, first thing I'm going to do is, from A, I'm going to measure a distance of 100 millimeters. I'm going to call that my point B. And now I have B at a height of 70. Okay, so from here now, it's like the other questions. They just worded differently and you have to kind of use a little bit of maths and understanding to work it out. So at A, let's do a vertical line there. Same thing at B. Now what I have to do is I have to put in my fill cone. So, difference in height from A to B, 80 take 70 is 10. 10 times my fill ratio, 10 times 1.5 is 15. So I'm going to get 15 on my compass, 15 millimeters, to use for my fill cone. Do it at the highest part of the road, which is at A. I'm going to put in my fill cone. If I do it on the southern side, I'm also going to do it on the northern side. And the next thing I'm going to do is construct a tangent from B. So there's my tangent from B, and we know that tangent is coming from a height of 70. So that's at 70. Now what I'm going to do is I'm going to step out in increments of 7.5 millimeters. So if I step out 7.5, it's going to go down from 70 down to 65 and so on, and likewise going upwards. So like I've done in previous questions, I like to set up a vertical height line, perpendicular line to my tangent. I'll actually set it up out here in this one. Keep it outside the question, keep it neat and tidy. And I'll do the same with this one up here. And I'm stepping out in 7.5 increments, 7.5 millimeters. So that's 70, that's 75. 80 is the highest it goes to. 2.5, 7.5, 7.5. I'll do one more here. I'll do the same up here. I need one more, maybe two. So if this is 70 here, this will be 75, 80, 65, 60, then we have 55 and 50. And I'm just seeing, does it go down to 50? I don't think it does. 55 is the lowest. So the same thing on the northern side of the road. So 70 here, 75, 80, as it moves away from the road, 65, 60 and 55. So at this point now, construct parallel lines to our tangent, or just to go through the points. So if that one was at 70, there's a 70, and just seeing there's another 70 over here. I'll do the ones going downwards first. So 65. Is there another 65? Yes, there is. Then I'll go down to 60. Yep, so 60 here and here. And finally 55 here and here. Now going upwards, 75 right here. And finally 80. Okay, do the same on the other side of the road. So there's 70. And do another 70. I'll do down here. I'll do the 65 then. So 65 here and here. 60 here and here. And you can see my 55 doesn't actually hit my 55 contour. So then on 75 and finally 80. So quickly sketch those in, so I'll speed up the video. So there we have it, folks. That is the last question completed on that page. A little bit different there on that one, where we kind of had to find the point P here, and we had to apply the gradient of the road. Okay, so hope you found those 4 questions helpful. They would be aimed at kind of the higher level aspect of road geometry. Okay.